Hello, Daniel.
How's it going?
Yeah, it's 4 o'clock. This meeting is essentially for me to go over chapter 2. But before we go to chapter 2, I want to know if you have any question. It seems you are the only one at this point.
No, I'm okay. I'm good. I'm all good to go.
Okay, did you have any trouble in chapter 1?
No, all good.
Oh, good. Okay, good. So what I will do is to quickly go over chapter 2. I will first share the screen with the PowerPoint. So chapter 2 is about equations and inequalities. So we are going to start with section 2.1, rectangular coordinate system. Do you have any idea about what a rectangular coordinate system is?
The name doesn't seem familiar, but I mean, I think maybe if I see it visually, I'll see it.
Yeah, you will know what it is.
Yeah.
Okay. So a rectangular coordinate system actually is when you have a graph. When you have a graph, you have an x-axis and a y-axis. So when you have x-axis and y-axis, we call it a rectangular coordinate system. We are going to see some examples here. So on a rectangular coordinate axis, we can, let me see if I will change this to a whiteboard. So on a rectangular coordinate system, you have two lines, and this one is the x-axis, and this is the y-axis. So if I have, for example, a point, let's say my point is 2 and -1, then x is 2 and y is -1, that point is somewhere here. So this is what we call a rectangular coordinate system. So we are going to look at some of the examples in the PowerPoint. Welcome to the class. So that is the first thing to do, how to plot a point on a rectangular coordinate system. You have the point, you move to the x-axis and the y-axis. So this is an example here. We have the point 3, 2 and the point 2 minus 4. 3, 2 meaning that we go 3 on x and 2 on y. And 2 minus 4, we go 2 on x and then minus 4 on y. So you have this point 3, 2 and you have this point 2 minus 4. Do you have any question as we are just starting on chapter 2, going over the PowerPoint?
No, I'm good.
Okay, so if you have any question, please just stop me, just speak, and I will answer your question.
Okay, thank you.
You're welcome. So when we have an equation, we may want to plot that equation on a graph. For example, this is an equation y equals to minus x plus 2. We can plot it on the rectangular coordinate system here. In order to do that, we assign values to x and values to y. With y equals to minus 3 plus 2, if x equals to minus 3, then y equals to, we will do minus 3, which is 3, plus 2, which is 5. Actually, this is 5, not 7. So that's the point we have here. If we have 0, I think something is not right here. I will rather change this 0 minus 3. This equation is not the right one. So this is 3 plus 2, 7. So normally we are supposed to plot this point here. If at 0, we are supposed to have 5. So this number should be not 5. This, let me put it back. This was 7. Let me put it back at 7. And if this is 7, and we have at 0, if we have 5, then this value should be 5. So to have 7, if we have minus 3 here, that should give 4. This is not the right equation. So I'm going to put it, I'm going to fit in here the right equation. I probably type it wrongly. The right equation should have at x equals to 0, we have 5, and at y equals to 0, we are having at x equals to 7, we are having 0. So x equals to 7, we are having 0. This is just another way to find the equation. So our equation here is y equals to ax plus 5, 0 equals to a at x equals to 7. So this is minus 5 equals to a7. This is a equals to minus 5 over 7. Y equals to minus 5x over 7 plus 5. This should not work. So I could change this, but I cannot change the graph because it's already fixed there. So I'm going to use what we have. We have at x equals to 0, we have 5. So a equals to ax plus 5. And then at x equals to minus 3, that is minus 3a plus 5, we want to have 7. So minus 3a is equals to 2. So a equals to minus 2 over 3. Minus 2 over 3. So this is minus 2 over 3. So this is the equation. Plus 5. Okay. So this equation, we want to represent it on this graph. So at x equals to minus 3, we will have 7. At x equals to 0, we have 5. At x equals to 3, we have 3. And at x equals to 6, we have minus 4 plus 5 equals to 1. I hope you all understand how to make this graph. So if you have a linear equation, y equals to, let's say, mx plus b, then you can plot the line on a rectangular coordinate system as this one. So how do we make a graph of a line? If you have an equation, y is a function of x, you may find the x-intercept by setting y equals to 0 and the y-intercept by setting x equals to 0. For example, if we have equation y equals to 3x minus 2, then if x equals to 0, y equals to minus 2, that is called the y-intercept. And when y equals to 0, x equals to 2 over 3, that is called the x-intercept. So on a rectangular coordinate system, we may want to find the distance between 2 points. One of the points have coordinates x1, y1, and the other one has x2, y2. So the distance between the 2 points is obtained by taking the square of the difference between the x values plus the square of the distance between the y value and take the square root. So for example, when we have 2 points, -3, -1, and 2, 3, we will take the difference between the x-axis. We will do 2 minus -3, which is 2 plus 3 equals to 5. And then for the y, we start with the second one, 3 minus -1, which is 3 plus 1 equals to 4. So we are going to have 5 squared plus 4 squared, which is 25 plus 16 equals to 41. And we take the square root of 41. That is the distance between the 2 points. When we have 2 points also on a rectangular coordinate system, we may want to find the midpoint of the 2 points. That is, if we draw a line joining the 2 points, what will be the middle? The middle is obtained by taking the average of the first values and the average of the second values. For example, here we have 2.7, -2, and 9.5. We will do 7 plus 9 over 2, and -2 plus 5 over 2. That gives us 16 over 2, 3 over 2, and that's the middle of the point -7 to -2, 9, 5. So we speak about the midpoint of 2 given points. 2.2, linear equation in one variable. That's the example we just had for that graph, was the example of a linear equation. So a linear equation is of the form ax plus b. That is, you have only one variable. So to solve a linear equation, you will send the variable on one side and the constant on the other side. The term with the variable here is ax. So b goes on the other side of the equality to becomes minus b. So the solution will be minus b over a. This will be an equation, a linear equation, when a is not 0. A should not be 0. These are some examples. We have 2x plus 7 equals to 19. So we will make on one side just the variable. So 2x will remain on the left. And we send 7 on the right. It will become minus 7. And we will have 2x equals to 19 minus 7 equals to 12. So x equals to 12 over 2, which is 6. So the solution to this linear equation is 6. Some people will say that add the opposite of the constant on both sides. That means add minus 7 to 7 and minus 7 to 19. This is aiming at having the variable on one side and the numbers on the other side. So a rational equation contains at least one rational expression where the variables appear in at least one of the denominator. A rational equation, for example, is A divided by B equals to C divided by D. When you have an equation like this, we do what we call a cross multiplication, which will result into AD equals to BC. Sometimes we have equations that are not linear, and using this cross multiplication, we can transform a rational equation into a linear equation. Let's look at this example. In this example, the equation is 1 over x is equals to 1 over 10 minus 3 over 4x. So we will transform the right side, which is the sum of two terms, two fractions. We will combine it to make it a fraction. And that fraction is 4x minus 30 over 40x. So our equation becomes 1 over x equals to 4x minus 30 over 40x. So using a cross product here, the relation will become 40x equal to x times 4x minus 30 if x is different from 0. So if x is different from 0, we can take it away, and the equation becomes 40 equals to 4x minus 30. But when x equals to 0, the equation is true, or the equation is true. So 0 is a solution to that equation. So that equation was actually a kind of quadratic equation, because it's only quadratic when x equals to 0, because if x is different from 0, it will cancel on both sides, and we will have 40 equals to 4x minus 30. This is a situation in which we have transformed a rational expression into a linear expression using cross multiplication. So the solution x equals to 70 over 4, which is 35 over 2, is one solution. We could not use x equals to 0 because we started with 1 over x. When you write 1 over x, 0 is not an option. You cannot divide by 0, as we learned in chapter 1. So the only solution for our original equation is 35 over 2. So the most general expression of the equation of a line is y equals to mx plus b. M is generally called the slope, and b is called the y-intercept. So the slope, what is actually the slope? The slope represents the number of changes in the y variable for each unit of change of the x variable. So you can always find it by getting 2 points of the line. And the slope is the difference between the y values divided by the difference of the x values. For example, if we have 2 points, 2 and negative 1, minus 5 and 3, we may want to find the slope of the line that will pass through those 2 points. So we will take the difference of the y values, which is 3 minus minus 1, divided by the difference of the x values, which is minus 4 minus minus 1. I'm sorry. The difference of the y value, yes, is 3 minus minus 1. That is 3 plus 1. Now the difference of the x value is minus 5 minus 2, which is minus 7. So the slope of the line that it will pass through those 2 points is minus 4 over 7. So given 2 points, the equation of the line will be, given any other point of the line, y minus y1 equals to m times x minus x1. So if we want to find the equation of the line that will pass through 2, negative 1, and minus 5, 3, we can pick any of those two lines and replace their values into this equation. If we take the first point, 2, negative 1, for example, then here, in this example, this will, let me type it here, example. This will become, let me use some, if we take the first point, 2, negative 1, the y value is negative 1. So we will do y minus minus 1, which will become y plus 1 equals to, we will do negative 4 over 7 times x minus x1. X1 here is the value with y equals to negative 1, so it's 2. So this will be x minus 2. So this is an expression of the equation, which will be equals to 4x over 7 minus 2 over 7. So this is the equation of the line that will pass through 2, negative 1, and negative 5, 3. As I said, if you have a question, you can stop me. So I've done one example. I'm going to skip this example. You can read it on the PowerPoint so that we save time. A linear equation. In general, a linear equation is expressed as ax plus by equals to c. But whenever you have an equation like that, you can always transform it into the standard form of y equals to ax plus b. So for example, if we have the equation y equals to 2x minus 2 over 3, that equation could be changed using cross product. We multiply through by 3. We have 3y plus 6x minus 2. That is, you have y equals to 2x minus 2 over 3. You multiply through by 3, you will have 6x minus 2 over 3, and use the cross product to get the equation. And in standard form, the equation becomes 6x minus 3y equals to 2. So the line, if a line has an equation of the form y equals to x, y equals to c, that line is a horizontal line on the rectangular coordinate system because its slope is 0. But if we have an equation like x equals to c, it will be a vertical line. The slope is generally infinity, but we say that there is no slope. So those are some examples of equation of lines. So if we have a line like y equals to mx plus b, you may want to know what are the lines that are parallel to this one. Two lines are parallel if they have the same slope. And two lines are perpendicular if the slope of one, m, is if the slope of the first one is m, the slope of any line parallel to a line with slope m is minus 1 over m. So if you have a line and you are told that another line is parallel or perpendicular to this one, use the slope formula, and given a point, you can find the equation of the line, which is either parallel or perpendicular to the line that you have. Example, find equation of the line perpendicular to 5x minus 3y plus 4 equals to 0 and passing through the point minus 4, 1. Let me change this to that passes through the point minus 4, 1. So the equation of the line will be transformed so that we can identify the slope and the intercept by solving for y. And we will get, instead of 5x minus 3y plus 4 equals to 0, we get y equals to 5 over 3x plus 4 over 3. So the slope of this line is 5 over 3. If we want a line perpendicular to this one, the slope of that line will be minus 1 over the slope of the line we have. So minus 1 over 5 over 3 will be minus 3 over 5. So having that, we will use the general equation of a line when we are given the slope. Remember, it is, we will find to find the equation of the line, we replace the point that we have here, 1 equals to minus 3 over 5 times x minus minus 4. So y minus 1 is not clearly written here. I will change it to this. So I told you about the equation of a line when you have the slope. It was y minus y1 equals to slope times x minus x1. So our x1 here is minus 4. That is what we have here. Our y is 1. So we have 1 y minus y1. And the equation of the line becomes y equals to minus 3 over x, minus 3 over 5x minus 12 over 5 plus 1, which is 5 over 5. That will give us y equals to minus 3 over 5x minus 7 over 5. So generally, we can have some real life situation that could be modeled into a linear equation. We will look at an example here. These are the expressions that you may have whenever you want to do a model. So if you hear an expression like one number exceeds another by a, it means if that number is x, the next one is x plus a. So if you hear the expression twice a number is 2x. One number is more than another number is x. If the other first number is x, the second number is x plus a. So using this type of expression, you can always transform a real life problem into a linear equation or a mathematical equation. So you can read this one on your own. So to model, the first thing to do is to identify the quantities that are known. Then assign variable to quantities that are unknown. If there is more than one unknown quantity, find a way to write the second unknown in terms of the first in order to simplify your work, using those expressions that we have on the previous slide. Then write an equation interpreting the words as a mathematical operations and solve the problem. Be sure that the solution can be explained in a word, including the unit of measurement. Example, find a linear equation to solve for the following unknown quantity. One number exceeds another number by 17, and their sum is 31. Find the two numbers. So if we say that one of the number is x and the other one is y, then y equals to x plus 17. We say that one number exceeds the other one by 17. So now we know that y equals to x plus 17 and x plus y equals to 31. Here I didn't write the x plus y. I can put here that let y equals to, let me just write here, and the second number as y equals to x plus 17. Then we can say that then x plus y equals to 31. Now we can solve this equation and have that x plus y will be x plus 17. That is 2x plus 17 equals to 31. So which means 2x equals to 31 minus 17. So 2x equals to 14, meaning that x equals to 7. So y equals to x plus 17 equals to 24. I will put here y to make it. So the two numbers are 7 and 24. You will have some of those type of questions on homework. So let's look at another example. Let me remove this. In this example, there are two cell phone companies that offer different packages. Company A charges a monthly service fee of $34 plus 0.0 cents per minute of talk. Company B charges a monthly service fee of $40 plus 0.04 minutes per talk time. Write a linear equation that models the packages offered by both companies. Now we are going to find out if the average number of minutes used each month is 1,160, which company offers the better plan? And how many minutes of talk time would yield equal monthly statement from both companies? So the first thing we will do is to state the relation between the bill. For company A, if the number of minutes of talk is X, then the bill will be A equals to 0.05 times X plus 34, which was the monthly charge. And for company B, it will be 0.04 times X plus $40. I didn't put dollars here. Let me just take this out. So if the company average minute, if the average number of minutes used each month is 1,160, then we will have for company A, replacing X by 1,160, we have 92 minutes, and for company B, 46.4. So company B offers the lower monthly cost of 86.40 as compared with the $92 for company. This is a mistake. This is 86.4. Compared with the $92 for company A. So if we want to know how many minutes will both company charge the same? We will set A equals to B in our equation and solve for X, and we'll find out that X equals to 600. So let's look at this other type of problem. The perimeter of a rectangle outdoor patio is 54 feet. The length is 3 feet greater than the width. What are the dimensions of the patio? So we know the formula for the perimeter of a rectangle is 2 times length plus width, which we can write as P equals to 2L plus 2W. We have two unknown quantities here, the length and the width. So we are going to use the information we had from the problem. The length is width plus 3, and we replace it in the formula for the perimeter to solve for the width, which we will end up getting that the width is 12 and the length will be 15. I am saying this so that we move to the next slide because you can read through to understand. Complex numbers. Complex number is very useful in mathematics, so we are just going to do an introduction to complex numbers. In chapter 1, we learn about real numbers. Here we are introducing complex numbers. So a complex number uses two real numbers, A and B, to express the complex number as A plus BI with I squared equals to -1. The complex numbers are useful because in some instances, we may want to take the square root of a negative number. This is only possible for complex values, complex numbers. So when we write a complex number as A plus BI, we call A the real part, B the imaginary part. So when B equal to 0, all real numbers are considered complex numbers. And when A equals to 0, the complex number we get are called the imaginary numbers. So for example, if we have a positive real number A, we will define the square root of minus A as square root of -1 times A, and dividing the square root, we will get square root of A times square root of -1. We remember that I square is -1, so square root of -1 is the same as square root of I square, which is I. So square root of -A will be I times square root of A. As examples, square root of -9 is 3i, square root of -25 is 5i, square root of -3 is I times square root of 3. So if we have a complex number, we can determine the imaginary part and the real part, as I explained to you. The part without I is called real, and the part with I is called the imaginary part. We can represent a complex number on a rectangular coordinate system as if it was a point. The real part will be on the x-axis and the imaginary part will be on the y-axis. How do we add or subtract complex numbers? To add complex numbers, we take it as if we were having 2 points. We add the real part together and the imaginary part together with I. For example, look here, we have 3 minus 4i plus 2 plus 5i. We will add 3 plus 2 and then minus 4 plus 5. So this will give us 5 plus I. What is a little bit complicated is multiplication. To do multiplication of complex numbers, we do the FOIL system. We multiply it as we have done in multiplication of binary operation. So the final formula you want to remember is that if you have two complex numbers, A plus BI and the other one C plus DI, when we multiply them, we will get for real part AC minus BD, and for imaginary part AD plus BC. Then we group the terms and add them to get a new complex number. Let's look at an example here. Suppose we want to multiply a real number by a complex number like in this first case. We just multiply 4 times 2 plus 4 times 5i. That gives us 8 plus 20i. If we are multiplying two complex numbers, both having real and imaginary part, we use the formula that we had above. So we will multiply. A here is 4, B is 3, C is 2, D is minus 5. So we will have 8 plus 15. The 8 is 4 times 2. And the C is the A, you multiply AC, and then you multiply BD. BD is 3 minus times minus 5, which is minus 15. Remember, we subtracted. We have AC minus BD. That is why we are having here 8 plus 15 instead of 8 minus 15. And for the imaginary part, we are going to do 4 times minus 5, which is minus 20, and 3 times 2, which is 6. So we get 23 minus 14i. So you will practice this more at homework. Very interesting about complex numbers is the conjugate of a complex number. The conjugate of a complex number is a number obtained by reversing the sign of the imaginary part. So if a complex number is a plus bi, then the conjugate of z will be a minus bi. Something interesting about conjugate is that if you multiply any number by its conjugate, you get the square of the distance between the two complex numbers. So in other words, you get the sum of the square of the values. So 1 over z, or 1 over z bar, is equal to z over a squared plus b squared. And 1 over z is z bar over a squared plus b squared. Those are examples that can, those are formulas for the use of a complex conjugate. So another example here, we might want to divide 2 plus 5i by 4 minus I. We are going to express the division here. 2 plus 5i divided by 4 minus I equals to, we will multiply the top and bottom by the complex conjugate of the denominator. That will help us to get rid of the complex or the imaginary part of the complex number of the denominator. When we do that, the denominator will become 4 minus I squared. I squared is minus 1, so 4 squared minus I squared is 16 plus 1. And the numerator, we just use the regular way of multiplying two complex numbers. We have 8 minus 5 plus 2 plus 20i. And the answer will be 3 over 17 plus 22 over 17. An interesting type of work with complex values is the powers of I. I raised to power 1 is I, and I raised to power 2 is I squared equals to minus 1, that we know already. And from there, I put it on 2 separate columns so that you can see how the odd values are playing. So I cube is minus I5 is I7 is minus 5, I9 is I11 is minus I, and this is how it is going to be changing. For the square, I square is negative 1, I4 is 1, I6 is negative 1, I8 is 1, I10 is negative 1, and so on. You can now observe here that I2 is 2 times 1, I4 is 2 times 2. So when the even number is the double of an even number, then the sign is positive. If it is the double of an odd number, the sign is negative. For example, you see I6 is 2 times 3, so you get minus 1. I8 is 2 times 4, you get 1. So you can use a similar argument here. So we see here that I1 is I3 is I plus 2, is negative 1, I4 is 1 plus 4 is I7 is 1 plus 6, negative I, and you can go that way Using that even part of it, you can decide whether it is an even as multiple of an odd number or multiple of an even number. So if somebody asks you what is, let's look at an example here. We want I-25, for example. To find I-25, we can just look at it as I times I-24. I-24 is I4 times I raised to power 6. I4 is 1. So 1 raised to power 6 is 1. So the answer is 1. If I get I-35, I raised to power 35, I may just look at the closest multiple of 2 or 4 that I can have. If it is a multiple of 4, I know that I raised to a multiple of 4 is 1. So I have here I4 raised to power 8. These examples are all multiple of 4, but you could also have multiple of 3. For example, if I want, multiple of 2. If I want I-32, I-31, for example. I-31 is 1 plus I-30. And then you can use that to find the value. So, but know that any power of I is either 1, -1, I, or negative I. I don't know about you, but if you feel tired, we can stop here and continue on Wednesday. I can do the same thing on Wednesday. But if you like, we continue. But I don't want you to feel overwhelmed with so much. What do you think? Feel free to say you are tired, because I don't want us to just spend so much time. But if you feel you are okay, we can continue for the remaining 15 minutes.
I mean, I think I'm fine. I don't mind continuing. I'm all good. So whatever
Okay.
whatever you guys want.
Yeah, I'm good with it.
Okay, thank you. Let's continue. I don't want you to feel overwhelmed. I don't want you to not to come the next time because it is taking too long. Okay, I will try to skip whenever it is very obvious, but sometimes I don't know what is really obvious. Quadratic equation. A quadratic equation, to solve quadratic equation, we need to recall what we will call here a zero product property. The zero product property is here. Let me put it this way. If you multiply two numbers and you get 0, at least one of the numbers must be 0. So we are going to need that in solving quadratic equations or equation with more than, of higher order than 1. A quadratic equation is an equation of this form: ax squared plus bx plus c equals to 0. That's what we call a quadratic equation when a is different from 0. We are going to look at several methods of solving this equation. We will first consider simple type of equation when a equals to 1. When a equals to 1, we will have an expression x squared plus bx plus c equals to 0. So we first observe if we can find two values p and q so that the product is c and the sum is b. If you can get two numbers, two integers, with product equals to c and sum equals to b, you have a solution. The solution are minus p and minus q. So that's the first step. Once you have an equation and a equals to 1, just look if there are any two integers with product equals to c and sum equals to b. This is an example. We have the equation x squared plus x minus 6 equals to 0. Here b equals to 1 and c equals to -1. So we are going to look at two numbers that if we multiply, if I take minus 6 times 1, the sum will be -5. If I take 6 times -1, the sum will be 5. I will look at the possible factors of -6 that will give me a sum of 1. An example is 3 and -2. If you do 3 times -2, you get -6, and 3 plus -2 is 1. So one of the value is 3, the other one is -2. If I had taken -3 and 2, the product will be minus 6, but the sum is not going to be 1. So the best solution is 3 and minus 2. So the solutions to this equation are now minus 3 and 2. Observe the change of sign here. We change the sign. After getting the two numbers whose product is C and the sum is B, change their sign to get the solutions to the equation. So sometimes we may have a quadratic equation and we are able to factor it into the product of two simple linear equations. In that case, we will use the zero product rule property to solve the equation. Let's look at this example. We have 4x squared plus 15x plus 9 equals to 0. Here a equals to 4, b equals to 15, and c equals to 9. We are going to look at two integers which product equals to AC, not C, AC, because we have A, which is not 1 here. It's a little bit more general form of what we did before. The product is AC and the sum is B. When we have that, we will take that sum to replace B. For example, here we have 4 times 9 equals to 36. So the factors of 36 whose sum is 15, we can get 3 here. 4 times 9 equals to 36, but the sum is not 15. But when we take 3 and 12, you will be trying and error until you get the best one. When we get 3 and 12, the product is 36 and the sum is 15. So we come back to our equation here. You see the equation here, and we replace the 15 by 12 plus 3. That will help us split the middle part of it. And as we split that middle part, we will be able to factor the first two terms into 4x times x plus 3, and the second term into 3 times x plus 3. So we now have a common factor. You learn about common factors in chapter 1. We now have a common factor, which is x plus 3, which we factor out and change our quadratic equation into the product of two linear expressions. We can solve each of them as we learn in in the previous section, and the solution will be minus 3 and minus 3 over 4. So sometimes we may just have a quadratic expression that could be expressed as x squared equals to a number k. For example, here we have x squared minus 9 equals to 0. In that case, we say x equals to plus or minus square root of k is the solution. In our case, the two solutions are 3 and minus 3. Remember that a quadratic equation can have no solution, can have a double solution, can have two solutions that are distinct. This is another example, but I will not spend much time here because in this solution, we try to do the completion of the square, which you can read it, but it's faster to use what we call the quadratic formula. The quadratic formula using the discriminant. The one we did before, the completion of the square with a equals to 1 is just a particular case of this. I want to save time by going to this one. So if you have a quadratic equation, ax squared plus bx plus c equals to 0, you can compute what we call the discriminant of the equation, which is b squared minus 4ac. If this discriminant, this is the discriminant, if this discriminant is negative, there is no real solution. There might be complex solution. That is, the solution could be complex numbers. We are not working on that now. But if the discriminant is less than 0, there is no real solution. But if the discriminant is 0 or more, if it is 0, there is a double solution. If it is more than 0, there is two distinct solutions. And the solution of the equation will be obtained as x equals to minus b plus or minus square root of the discriminant divided by 2a. This is called the quadratic formula to solve a quadratic equation. With this method, you can solve all quadratic equations. If you don't want to waste your time using completion, using factoring, or using the beginning of the square, you just use the quadratic formula. But I have given all of those methods to you so that you should know what it means. This is an example. We want to solve the quadratic equation x squared plus 5x plus 1 equals to 0. So we have a, b, and c. We can compute the discriminant, which will be 5 squared minus 4 ac. A is 1 and c is 1. So it is 5 squared minus 4. Now b is 5, so the solution will be minus b plus or minus square root of 21 over 2. Here is 2a, because a is 1, we have it over 2. The quadratic formula is very fast. And 2.6, we are going to look at some other type of equation. We might have an equation that involves rational exponents. Rational exponents, like the square root, the square root is a rational exponent, which the exponent is 1 over 2. And so I'm going to give some example here. Suppose we want to solve the equation, look at this one. 5 raised to power 5 over 4. 5 raised to power 5 over 4. What I will do is that I will recall that 32 is a 5 power of 2. So I will replace that into the expression of x. 32 here is a 2 raised to power 5. So I will express x raised to power 5 over 4 as x raised to power 1 over 4, all raised to power 5. Remember the rule of exponents. When you multiply, when you raise a power to another power, you multiply. So that will help me to have something raised to power 5 equals to 2 raised to power 5. That something is x raised to power 1 over 4. So x raised to power 1 over 4 equals to 2. Making that x equals to 2 raised to power 4, which is 16. So you play with the rational using these essential rules of rational, which is here. So sometimes an equation might look a little bit with higher power, and you can want to factor it. So just rewrite your equation like we can do here. 5x4 equals to 80x squared. Observe very well and put all 5x4 minus 80x squared equals to, we can factor 5x squared to get x squared minus 16, and then solve using the zero product rule, zero product property, which will have 5x squared equals to 0, x minus 4 equals to 0, or x plus 4 equals to 0. We have 3 solutions here, 0, 4, and minus 4. If we have, for example, an equation here involving the square root, we want to make sure that we know that the square root is never negative. We have not written it here, but always return your values into the equation to be sure that you have the right solution. So what we will do is we square both sides of this equation and get rid of the square root. And the equation becomes 3x plus 18 equal to x squared. So which gives this quadratic equation. And with this quadratic equation, we can quickly see that minus 6 times 3 equals to minus 18, and minus 6 plus 3 equals to minus 3. So the solution to this equation are 6 and minus 3. Now we go back and replace into the equation to know which of those two is actually the solution. If I replace up here by 6, we have p equals to minus 6, the solution is 6. I will have 3 times 6 is 18 plus 18 equals to 36. Square root of 36 is 6. So the solution to this equation, 6, is good. that is the square root of 3x plus 18 equal to x. If I replace here now by minus 3, I will have 3 times minus 3 equals to minus 9. And then when I do minus 9 plus 18, I get 9. So square root of 9 is 3. Remember that the solution is supposed to be minus 3, not 3. So when q equals to 3, the actual solution is the opposite. So that means minus 3 is not a good solution for this equation. This is a mistake. So we may have equation involving absolute value. The definition of the absolute value is that when a number is positive, the absolute value is exactly that number. But if a number is negative, the absolute value is the opposite of it. For example, absolute value of 2 is 2. Absolute value of minus 2 is minus minus 2. So don't get confused with this minus. It's because the number is negative. When you put the minus there, the number becomes positive. So you will have equations involving absolute value like these ones. So if the absolute value equals to c and c is negative, there is no solution. Absolute value cannot be negative. If the absolute value equals to c and c is 0, it's just a simple linear equation, ax plus b equals to 0 with a single solution. But if c is positive, remember that absolute value of positive and negative number equals to the same positive value. So there will be two solutions. So we still have few slides and we are getting almost to time. And look at this example. If we have 6s plus 4 equals to 8, we can write it that it means 6s plus 4 equals to 8 or 6x plus 4 equals to minus 8. And then we solve both equation to have on one side x equals to 2 over 3 or x equals to minus 2 by solving each of these linear equations. That's how you solve equation involving absolute values. I'm going to skip this. Sometimes an equation could be like this, any of these three. Look at these three equations. What you will observe here is that if you look at the middle term x squared here, the square of it is x4. If you come here and you see the middle term is x3, the square of it is x6. Here the middle term is x1 over 3, the square of it is x2 over 3. So this is a disguised quadratic equation. So what you will do in this case is to make a substitution. You can make a substitution like u equals to the middle variable. For example, here we have 3x4 minus 2x squared equals minus 1 equals to 0. I will set u equal to x squared and change this equation into a quadratic equation. After solving that quadratic equation, I should remember to set back the values. If I had, for example, u equal to x squared, and I get u equal to minus 1 over 3, the solution cannot be a real number because the square of a real number cannot be positive. So I have u equals to 1 is the only one that can be used to find a real solution, which will be x equals to negative 1 or 1. So that's what I've just explained here. This is a complex solution. It's not a real solution. It's a complex solution. So we are left with 2.7, and are we okay? Can we stop here, or you want us to just finish?
I'd rather just finish it than rather than doing another call just for this. You know what I mean? I'd rather just
on Wednesday you come and we will discuss homework and any question you have. What about that?
Yeah, that works too. Whatever you want. I don't know.
Okay, it will take me maybe 10 minutes and we will be done. Thank you.
Yeah, that's fine. Yeah, we'll just finish.
Okay, Brian, are you okay with that?
Yeah, that's okay.
Thank you, thank you.
Mhm.
Okay, let's look at interval notations of inequalities. So when we have an expression like all x, this means all x such that x is greater than a and less than b. All x, then we use parentheses like this, and it means that the values that are in these intervals are strictly greater than a and strictly less than b. So when we want to express the set of values that are greater than, strictly greater than a number a, we will write it as an open interval from a to infinity. And below it is from minus infinity to b, meaning values that are less than b. This one is not correct. Let me change this to this. So we use square, like you see me changing on the fourth row. When you have greater than or equals to, we use square, the square bracket, to mean values that are greater than or equals to a. If we are looking for values that are less than or equals to b, we will go from minus infinity to b, close with a square bracket. In this case, we are taking values that could be a, bigger than a, but all less than b. We start with a square bracket and a regular parenthesis. That means b is not part of it. Here, a is not part of it. Anything between a and b, including b, but except a. Here, this square bracket from a to b means everything between a and b, including a and b. Here is the union of two intervals, one values that are less than a, another one values that are bigger than b. Here is the representation of all real numbers from negative infinity to infinity. In homework and quizzes, you will have questions where you will be asked to use the appropriate interval to represent a set of real numbers. These are some properties of those inequalities. If you have a less than b, if you add the same number of both sides, the inequality will still be the same. But if you are doing multiplication, you have to be careful. If you are multiplying by a positive number, the inequality remains the same. But if you are multiplying by a negative number, you will reverse the inequality. For example, if I say that negative 2 is less than 1, if I multiply both sides of the inequality by negative, then let me just give that type that example here. I will erase it after. We have negative 2 is less than 1. If I multiply both sides of this equality by negative 1, I will have 2 is greater than negative 1. That's what I mean. So when you are multiplying an inequality by a negative number, reverse the inequality. So this is an example of inequality. This is an inequality. 13 minus 7x is greater than 10x minus 4. We will solve it like a regular equation until we get to this point. Minus 17x is greater than or equals to minus 17. And we will now be careful about the negative and inequalities. When we divide both sides by negative 17, we will reverse the inequality to have x is less than or equals to 1. So in interval form, it will be negative infinity to 1, closing the bracket. Suppose we have a compound inequality like this one. To solve a compound inequality, you may divide them into two. This is 3 is less than 2x plus 2 less than 6. I can add minus 2 on each portion of that inequality. That's a way to solve. And I will have 1 is less than or equals to 2x less than or equals to 4 and solve it that way. Or you just separate it to make it easy into two different inequality. 3 is less than or equals to 2x plus 2 and 2x plus 2 is less than 6. When I do that, I will split my equation and solve on one side, I will have here, you see, minus 2 come here, is 1 is less than or equals to 2x. That gives half is less than x. And on this side, I will have 2x is less than 4. That is x is less than 2. So this is the inequality. Half is less than x and x is less than 2. We can rewrite it as x is greater than half and less than 2. That's how we can combine two inequalities. So we will complete it with the rule of absolute values. Inequality and absolute value. Look at this. Absolute value of x is less than k. If absolute value of x is less than k, then x is between minus k and k. That is another way to express x is between minus k and k. But if you say absolute value of x is greater than k, it will mean that x is outside the interval minus kk. So that is a remark. Let's look at an example here. Describe all values x within a distance of 4 from the number 5. That means the distance between x and 5 is absolute value of x minus 5. That's the meaning of the distance between two numbers, is the absolute value of their difference. So if they are within 4, that means the absolute value of x minus 5 is less than or equals to 4. So we want to solve this inequality. So if you do absolute value of anything less than or equals to a positive number, you can enclose that thing in between the negative and the positive of that positive number. You see, we have absolute value of x minus 5 less than or equals to 4. Using the inequality for absolute value, it means minus 4 is less than or equals to x minus 5 less than or equals to 4. So we can solve this equation. Look at what I will do here. I add 5 on each portion of this inequality, because adding numbers to inequality does not change the inequality. If I add 5 everywhere, I will do 5 minus 4 is 1, and 4 plus 5 is 9. X minus 5 plus 5 is x. So the inequality becomes x greater than or equals to 1, less than or equals to 9. And in interval form is from 1 to 9. Thank you very much. We are going to save the recording for all the students that have missed. So it's always good to help others. So I thank you guys for coming. On Wednesday, same time, I will want to hold like a help session for those who have questions on homework or quizzes. You can start trying to do your homework and quizzes today to do as much as possible, so that on Wednesday, if you have questions, we look at it all together.
All right, sounds good. Thank you.
Thank you so much, guys.
Have a good one.
Have a nice evening.
You
You
too.
too.
Thank you.